A parallel plate capacitor of 300 microfarad is charged to 200 volt. If the distance between its plates, it's supposed to be plates, if the distance between its plates is half, what will be the potential difference between the plates and what will be the change in stored energy? First, if I draw a diagram, so I am having a parallel plate capacitor. So this parallel plate capacitor is charged to a potential difference of 200 volt. So this is potential difference of 200 volt, and it's having charge, that is plus Q, and this is minus, that have a positive charge Q and minus Q. Now, in my first case, I would like to find what is the energy stored and what is the charge. So if I write that given C equal to 300 microfarad and potential V equal to 200 volt, and to find out the charge, therefore charge Q equal to CV, that is the relation between charge and potential. Now if you can substitute that you can get 300 times micro 10 power minus 6 times 200. So charge Q equal to 6 times 10 power 4 times 10 power minus 6. So charge Q equal to 6 times 10 power minus 2 coulomb. So that is the charge on the capacitor plates. Once we know the charge on the capacitor plates, it is easy to find the what is the energy stored. Therefore, energy stored in the capacitor plate. Energy stored in the capacitor. You can use any formula. Potential energy stored U equal to half CV square or a half QV. So it depends upon the values what we are having. So I can use the half CV square. So half, and capacitance is given 300 micro 10 power minus 6, and for potential, that is the 200 volt, that is the 200 square. Now let's simplify this. If we simplify that, potential energy U equal to half times 300 times 10 power minus 6 times, here it equal to 4 times 10 power 4, 100 square, that is 10,000. Now 2 and 4 gets cancelled 2 times. The energy stored equal to 6 times 10 power 6 times 10 power minus 6. Oh, it's easy calculation. U equal to 10 power 6, and the 10 power positive 6 and the negative 6, they both gets cancelled, and we got that potential energy U equal to only 6 joules. In this case, potential energy U equal to 6 joules. If I cut this softly, 10 power 6, then now that is what happens when the capacitor is connected to 200 volts. Now for the second case, so the condition is given that if the distance between the plates is reduced half, if the distance between the plates is half, it means it becomes d by 2. Earlier, if we take the distance between the plates as d, if this case the distance between the plates as d, now in the second case the distance between the plates will becomes half. Now I would like to find what is the energy. To find the energy, first I need to find the if there is any change in the capacitance or any change in the potential difference. Since capacitance of a capacitor C is equal to epsilon naught A by D, so if D becomes D by 2, and therefore capacitance becomes the new capacitance C dash equal to epsilon naught A upon D upon 2. So I would like to write it here clearly. Let me take this space. Capacitance of a capacitor C equal to epsilon naught A upon D. If D equal to D up by 2, the new capacitance C dash equal to epsilon naught A upon D by 2. So therefore C dash equal to, that implies I can take the 2 numerator, 2 times epsilon naught A upon D. Now if you can see epsilon naught A in the place of epsilon naught A, if you can substitute the value of C, now I can get that C dash, the new capacitance C dash equal to 2 times C. It means the capacitance value gets doubles. Yeah, it's a common sense. Since we know from formula, if the distance becomes half, capacitance becomes doubles. Therefore, the new capacitance C dash equal to 2 times C. So that is the first change we can observe. The new capacitance C dash equal to 2 times C. And what about the potential? Now the potential difference between the plates. Why the potential difference we need to see? Because capacity is equal to Q by V. If the Q changes, and potential also will be changes. Now if I take the new potential difference as V dash, therefore V dash equal to charge do not change, Q upon, and the new capacitance is C dash. Now the new potential difference equal to Q upon by 2C, means the potential becomes half. Now if you can find that what is the new new potential V dash. Now the charge equal to 300 micro, 300 times 10 power minus 6 times 2 is there, and the capacitance of a capacitor. Capacitance of a capacitor equal to 300, and the capacitance of a capacitor is 300. Charge Q here it is 6 times 10 power minus 2. That is 6 times 10 power minus 2, and the capacitance of a capacitor 300 micro, 10 power minus 6. And if we can do simplification, this changes as the new potential difference V dash equal to 6 times 10 power minus 2 upon 6 times in the denominator 2 zeros and 10 power minus 6, it goes to 10 power minus 4. If you can cut, 10 power 4 goes to numerator, it will becomes 100 volt. Therefore the new potential difference V dash, we got it, that new potential difference V dash equal to 100 volt. Now from this, can we figure it out what is the energy stored in the capacitor? Therefore the energy stored in the capacitor after distance between the plates decreased. After distance between the plates becomes half. We can use same potential difference. So in this case, let me take as an u dash, which equal to half c dash v dash square, half cv square. Therefore u dash equal to half times c dash value. So c dash, here we got it that c dash equal to 2 times c, which equal 2 times c, and v dash value here I got it 100 square. 100 square. So this value you can substitute at there. Now capacitance of a capacitor, if you can substitute that value at here, and let's do the simplification. U dash equal to half times 2 times capacitance of a capacitor, that is a 300 micro, 10 power minus 6 times 100 square, it becomes 10 power 4. Directly write that 10 power 4. 10 power 4. Now let's simplify this. 2 gets cancelled, and 10 power 4, sorry, 10 power minus 6 and 10 power plus 6. Therefore u dash equal to 3 times 10 power minus 6 times 10 power plus 6, and these 2 gets cancelled. The new potential energy u dash equal to 3. Now here we can see, before the distance becomes half, before the first case, so the energy stored equal to 6 joules. When the distance between the plates becomes half, the energy stored becomes 3 joules. It is 3 joules. Therefore the energy lost, which equal to, if we can write that, u dash minus u is equal to 3 joules minus 6 joules. The lost in energy is equal to minus 3 joules. Don't be confused, otherwise if you can flip the terms at here. Now if you can take that u minus u dash, we need to find just the difference, and the minus sign tells supports it's the 6 joules minus 3 joules, which equal to plus 3 joules, and the loss in the energy. So this energy loss will be dissipated in the form of either electromagnetic radiation or in the form of heat energy.